Dear students, Department of Pre-University Education has released a model question paper for the academic year 2021 and 22. So in this year question paper, many changes have been made. More number of questions are given so that students get more choices to answer the questions. So in today's class, we are going to solve this model question paper. In this video, we are going to solve part A of this model question paper. Part A contains 1 mark questions. So question number 1, answer any 10 of the following questions. So each question has 1 mark, so total 10 marks. In previous pattern of the question paper, there used to be 10 questions and you had to answer all the 10 questions. You had no choice in this part A. But in this new pattern, 15 questions have been given and you have to answer only 10 questions. Means you have choices. Okay, you can leave any 5 questions. Out of 15, you have to solve any 10. And interestingly, first 10 questions are from the part 1 book. Means if you study part 1 completely, you can answer 10 questions. Okay, so to completely get 10 marks from this part, you need not read both the parts of the textbook. If you just read the first part completely, you can answer 10 questions. But anyhow, for the knowledge sake and for the competitive exams, if you are preparing for the competitive exam, you have to study both the parts of the textbook. Okay, so if your intention is just to prepare for the board exam, then if you read only part 1 book, you can answer all the 10 questions from part A. Okay, now let us see all these questions from part A one by one. So the first question is, write the physical quantity whose SI unit is coulomb. Write the physical quantity whose SI unit is coulomb. You know that coulomb is the SI unit of electric charge. This time they have twisted the question. Usually this question will be asked. Usually this question appears every year almost. SI unit of electric charge. SI unit of electric charge is coulomb. We know it very well, but they ask this question in different ways. Sometimes they ask what is the SI unit of electric charge. Sometimes they ask define SI unit of electric charge. But this time they have reversed this question. They have given the unit and asked the physical quantity. Write the physical quantity whose SI unit is coulomb. So the answer is electric charge. So coulomb is the SI unit of electric charge. So electric charge. If you write just electric charge, you will get 1 mark. Okay. Then second question. Define linear charge density. Define linear charge density. Yes. Linear charge density can be defined as charge per unit length of conductor. Just if you write this much, charge per unit length of conductor, you will get 1 mark. So charge per unit length of conductor is called linear charge density of the conductor. Can you tell me what is its SI unit? It is charge per unit length, means charge by length. Charge by length means its SI unit will be coulomb per meter. Okay. Sometimes they they may ask you to write SI unit of linear charge density. Similarly, they may ask you define surface charge density or volume charge density. Surface charge density means it is the charge per unit area. Volume charge density means charge per unit volume of the conductor. Okay. So for this question, define linear charge density. The answer is charge per unit length of conductor is called linear charge density of the conductor. Okay. Then question number 3. How does resistivity of the nichrome vary with absolute temperature? We know very well that resistance of a metal depends on temperature. With increase in the temperature, resistance increases, and with the decrease in temperature, resistance decreases. But here they have asked, how does the resistivity of a nichrome? Nichrome is an alloy. Nichrome is an alloy of nickel, iron, and chromium. So how does the resistivity of a alloy vary? See, the resistivity of an alloy depends very less or very less on temperature. That means the variation in resistance will be very small with temperature. But in metals, variation of resistance is higher. Okay. So the answer for this question, how does resistivity of the nichrome vary with absolute temperature? So the answer should be the resistivity varies very slightly, or the variation of resistivity is very less with temperature. The variation of resistivity of nichrome is very less or very small. This you can write this way, or but anyhow, with increase in the temperature, resistivity increases. Resistivity of metals also increases, and resistivity of alloy also increases, but this increase will be small in case of alloys. That is why alloys are used in the construction of the resistors, because their temperature dependence will be less. Okay, so the variation of resistivity of nichrome is very less with temperature. Very less with temperature. Okay. Yes. You can write this, or you can also write resistivity increases slowly with temperature. Resistivity increases slowly with temperature. Anyone, or you can just, if you write resistivity increases with temperature, then also you will get right. Sorry, you will get the marks. Okay. Okay. Next question. The colored rings marked on a carbon resistor are red, 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 and silver. What is the tolerance of this resistance? See, now they have asked this question in a different way. Usually, if you see the previous year question papers, they will give colors on a color band, and they ask what is the resistance value. For this time, they have asked what is the tolerance of the resistor. Okay. Yes. See, you know that in a color band, the fourth color always represents tolerance. Okay. Here four colors are given: red, 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 and silver. Here fourth color is silver. So silver indicates tolerance. uh, fourth color to indicate tolerance, two colors, silver, gold, and no color. If gold is used, then tolerance is plus or minus 5%. If silver is used, then the tolerance is plus or minus 10%. And if fourth color is absent, if no color, fourth color is not present, then tolerance is plus or minus 20%. So in this case, the fourth color is silver, therefore tolerance is equal to plus or minus 10%. Then what is this tolerance? I hope you know this. Tolerance is the possible variation in the resistance value. Okay. Uh, when resistors are manufactured, uh, the resistance value is not precise. There may be slightly variation in the resistance value. So that variation is expressed in terms of tolerance. Okay. So it is the possible variation in the resistance value. Okay. Yes. But can you tell me what is the resistance value here based on this color code red, 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 and silver? Uh, I hope you know how the color coding are used. Uh, color coding black, brown, red, orange, yellow, hmm, green, blue, violet, gray, white. These are the colors used in color coding. So black color indicates 0, brown indicates 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, and white 9. Here the given colors are red, 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 and silver. Here the first two colors give the first two significant figures in the resistance value. Here red indicates 2. So first two significant figures are 2, 2. And third color gives power of 10. So it is 10 to the power 2. And fourth color gives tolerance. So this gives you resistance value, that is ohm. Then fourth color gives you tolerance, that is 10%. So the resistance value is 22 into 10 raised to 2 ohm plus or minus 10%, or you can write 2200 ohm plus or minus 10%. But this is not required. Uh, Here they have asked only tolerance. So tolerance is indicated by fourth color. Your fourth color is silver. Therefore tolerance is plus or minus 10%. So you should write only this much. Okay. That this I gave you for your information. Okay. Then next question. Fifth question. What is Lorentz force? What is Lorentz force? When a charged particle moves in a combined electric and magnetic field, the force acting on the charged particle is called Lorentz force. Okay, the force acting on a charged particle, the force acting on a charged particle moving in a combined electric and combined electric and magnetic field. Combined electric and magnetic field is called Loring force. See, when a charged particle moves in a combined electric and magnetic field, here both electric field and magnetic field exert force on the charged particle. Okay, therefore the total force due to both electric field and magnetic field is called Loring force. You can write this much, or you can write expression for that. See, the force due to electric field will be QE, and force due to magnetic field will be Q into V cross P. So this is the expression for Loring force. You can write this also, or you can write this definition. Okay. The next, state Gauss law in magnetism. State Gauss law in magnetism. So Gauss law in magnetism is referred to magnetic flux. So the total magnetic flux, according to Gauss law, the total magnetic flux through any closed surface, is always zero. The magnetic flux through any closed surface is always zero. This is Gauss law in magnetism. You have learnt Gauss law in electric for electric field also. What is that Gauss law for electric field? The electric flux through any closed surface is equal to 1 by epsilon naught times the total charge enclosed. But here the magnetic flux through any closed surface is always zero. Okay. Now the seventh question: draw the pattern of magnetic field lines for a bar magnet. Okay, magnetic lines for a bar magnet. Let us draw the bar magnet. Suppose this is the North Pole and this is South Pole. The magnetic lines always start from North Pole and end at South Pole. So we'll start from here and we end at South Pole. And the direction is always from north to south. So you can show one more line this way. Yes, if you just draw these two lines, enough. Okay. Or you can show some more lines. Yes, this way. You can draw many such lines. So always these lines start from North Pole and end at the South Pole. So this is the pattern of magnetic field lines for a bar magnet. Now question number 8. What is wattless current? The definition is the current in a pure inductive or capacitive circuit is called wattless current. This is the answer. Okay. The current in a pure inductive or capacitive circuit. Pure inductive circuit means a circuit containing only inductor. Pure capacitive circuit means a circuit containing only capacitor. So a circuit containing only inductor or only capacitor is called a wattless current. Why? Here watt is SI unit of power, and you know that the average power. This is for your additional information. This is the answer. If you write this much, you will get the marks. This I am giving you for your information. See, power is given by ERMS into IRMS into cos pi. Here pi is the phase difference between E and I. In pure inductive or capacitive circuit, pi, that is phase difference between current and voltage, is pi by 2. That is this phase difference is pi by 2 or 90 degree. Okay. So when you put this value here, pi, so cos 90 is 0. Then power becomes 0. So power is 0 means watt is 0. That is why this is called wattless current. Okay. So the current in a capacitive circuit or a inductive circuit is called wattless current. This is the answer. Next question. Mention the angle between electric field and magnetic field in an electromagnetic wave. Yes, very simple question. Electromagnetic wave means what? A wave which travels in the form of alternate electric and magnetic fields mutually perpendicular to each other and also perpendicular to the direction of propagation. So, electromagnetic waves propagate by producing alternate electric and magnetic fields mutually perpendicular to each other. Therefore, the angle between electric field and magnetic field in electromagnetic waves is 90 degree. So, the answer is 90 degree. Or you can write pi by 2. Okay. Yes. Then name the electromagnetic wave which keeps the earth warm by greenhouse effect. Name the electromagnetic wave which keeps the earth warm. The answer is which electromagnetic wave is responsible for warmth of the earth? Infrared waves. Okay. Here what happens when the sunlight falls on the earth? The earth becomes hot and it starts emitting infrared radiation. You know that all hot bodies emit infrared rays. All hot bodies are the sources of infrared waves. So here, when sunlight falls on the earth becomes hot and it starts emitting infrared waves. And these infrared waves will be absorbed by carbon dioxide and water vapors present in the atmosphere. As a result, the temperature of the atmosphere also increases. This is called greenhouse effect. So therefore, infrared waves are responsible for the warmth of the earth. Okay. Then write the condition for diffraction maximum in terms of wavelength of light. How does the resolving power of a telescope change on decreasing the aperture of its objective lens? You know that resolving power of a telescope is given by 2a divided by 1.22 lambda. Here 2a is the diameter of the objective lens, or it is also called aperture of the objective lens. So from this equation you can see that resolving power is directly proportional to aperture. So the answer, how does the resolving power of a telescope change on decreasing the aperture? So here resolving power is directly proportional to the aperture. So if the aperture decreases, resolving power also decreases. So the answer is the resolving power of a telescope decreases. You just write the answer decreases. How does the resolving power of telescope change? Answer is it just decreases. No need to write the expression. Okay, next question. Define impact parameter in alpha ray scattering experiment. So we have learnt Rutherford alpha ray scattering experiment. So here what is impact parameter? It is the perpendicular distance between perpendicular distance between initial velocity of incident rays, that is incident alpha rays, and the center of the nucleus. Okay, it is the perpendicular distance between the initial velocity of the incident alpha rays and the center of the nucleus. Next question. In which type of extrinsic semiconductor holes are minority charge carriers? Okay, extrinsic semiconductor. Extrinsic semiconductor means impure semiconductor. You know that there are two types of impure semiconductors, N-type and P-type. In N-type, N means negative. Negative means electrons. So electrons are the majority carriers. Electrons are majority charge carriers and holes are minority charge carriers. Holes are minority. Minority means less number. And in P-type, P means positive. Holes are positive, right? So holes are majority here. Holes are majority and electrons are minority. So here the question is, in which type of extrinsic semiconductor holes are minority? So holes are minority in N-type. So your answer should be N-type. Just if you write N-type, you will get the marks. Okay. No need to write all this. This is for your information. I have given this information for your knowledge. No need to write all this. The answer should be in one line or in one word. If you just write N-type, you will get 1 mark. Okay. The next question. Draw circuit symbol for PN junction diode. Okay. Circuit symbol for PN junction diode. Very simple. See, this is the circuit symbol. So this is P and this is N. Okay. So we completed all the 15 questions here from part A. In the next video, we will solve part B. Part B contains 2 mark questions. Okay. So in the next video, we will solve part B. So I hope you like this video and this was useful for you. So if you like this, please don't forget to subscribe to this channel. Subscribing will not cost you anything. Okay, it is free. If you subscribe to this channel, then I make new videos. When I make videos of next part, part B, you will get immediate notification and you can see that video. So in this channel, I am uploading videos which will be very useful for you for the preparation for your board exam and also for the competitive exams like JEE and NEET. Therefore, Without any hesitation, please subscribe and share it to your friends. Thank you.